Good morning, everybody. Today we're going to be talking about oxidation numbers in redox reactions. And what are these? Well, they're basically the charge an atom would have if all of its bonds were ionic. And it's used to track electron movement, which is going to make a lot more sense when you guys start talking about voltaic cells or electrolytic cells later on when you get to electrochemistry. And determining these numbers, you have 6 rules. The first one is that if an atom is actually bonding ionically, just give it its preferred charge. If it's if it's oxygen, the number is going to be -2, unless it's bonded to fluorine or it's in a peroxide, which are rare instances. You can look up the rule if that happens. H is +1, unless it's bonded to a metal, in which case it will be -1. Pure elements are 0. Neutral compounds have oxidation numbers that sum to 0, and polyatomic ions have oxidation numbers that sum to their charge. Now, these rules are going to require you to do a little bit of review, but once you get them down, these problems will start going pretty quick, and I want to show you 3 of them to get started. So, for this first one, whenever you're completing a problem like this, you're probably going to have a table of polyatomic ions, and there are a few that are appearing in this problem. The first one here is permanganate. This is a polyatomic ion where the entire thing has a charge of -1. Nitrite also has a charge of -1, and sulfate is -2, and sulfate appears again over here, and here this is similar to nitrite, but this is nitrate. It also has a charge of -1. Once we've identified all of our polyatomic ions, we can then take a look to see if there's anything we already know. Well, there are no F's up here, there are no peroxides, and there are no H's bonded to metals. So I'm going to go ahead and I'm going to plug in -2 and +1 for my oxygens and my hydrogens. Then I can notice that potassium is taking part in an actual ionic bond, and potassium's preferred charge is +1, which also helps me with rule 5, because entire compounds that are neutral need to have oxidation numbers that sum to 0. +1 -1 is 0. +1 -1 is 0. +1 -1 is 0. And here it is +1, but there's 2 of them. 2 - 2 is 0. K is done. Now let's take a look at N. Well, over here, this whole thing adds up to -1, and O we said was -2. If there's 2 oxygens, that means we have something -4 is -1. So in this case, N over here is +3. 3 -2 -2 is -1. Over here, we're going to figure out S. We have S and 4 oxygens add up to -2. 4 oxygens, if they're each -2, is -8. So something -8 is -2. 6. And the good thing about these is that once you've figured out a polyatomic ion, you have figured it out. Every time SO4 appears, the S and the O are going to be the same. Now let's take a look at manganese on this side. Well, manganese plus 4 oxygens adds up to -1. Oxygen is -2, and so there are 4 of them. My total negative is -8. and I have something minus 8 is negative 1. That has to be plus 7. With everything done on the left, let's go over here to the right. Manganese, again, is bonded to sulfate. But this entire thing, manganese sulfate, is neutral. So this manganese has to subtract to 2 to equal 0. It must be 2. Now let's take a look at nitrogen. Nitrogen over here, instead of being bonded to 2 oxygens, is bonded to 3. But still, each oxygen is minus 2. Minus 2 times 3 is minus 6. And n minus 6 equals negative 1. N must be plus 5. When you're doing these types of problems, you want to look. Did anybody's charge change? And if it did, we need to look for oxidation and reduction. Oxidation is when the charge increases. Reduction is when it decreases, reduces. We can see that nitrogen was oxidized. It went from 3 to 5, while manganese was reduced. Its oxidation number went from 7 down to 2. If you need to replay that, do it, but let's just keep going through a few more problems. Okay. Up here, there's a lot we can fill in right away. There are no F's. There are no H's bonded to metals. So I know that my oxygen is minus 2. My hydrogen is plus 1. And over here, dichromate is another polyatomic ion. Dichromate has a charge of minus 2. And there are 2 potassiums. So 2 Ks minus 2 equals 0. There's no charge here. That means each K is plus 1. And that same thing is happening over here, because OH is hydroxide, and it adds up to negative 1. But that should make sense, because we said that oxygen is minus 2 and H is plus 1. Negative 2 plus 1 is negative 1. Now let's look at our S's. Well, on this side, S is pure. There's just S. There's 3 of them, but there's still just S. Anything that's pure has a 0 oxidation number. Chromium over here, we can do a little bit of math. This whole thing adds up to negative 2. So I can think about it like this. And oxygen, we said it's negative 2. And we can simplify this. Chromium is plus 6. 12 minus 14 is negative 2. And we have 2 things that add up to 12. 6 plus 6. On this side, over here, Cr2O3, there's no charge. And so this whole thing is going to be adding up to 0. And again, we can kind of do some math. 2 Crs minus 6, because there are 3 oxygens and each one is negative 2, equals 0. Here, chromium is plus 3. Sulfur, on this side, is bonded to 2 oxygens. Each oxygen is minus 2, so the total negative is negative 4. So S minus 4 equals 0. S is plus 4. Once you finish, look for oxidation, look for reduction, and you will see S was oxidized. Its charge went up from 0 to plus 4, while chromium was reduced from plus 6 down to plus 3. Let's do one more example. Down here, there's a couple things we can rely on that are really helpful. Number one, we already figured out nitrate. We said that the N is +5 and the O is -2. We already figured out permanganate. Mn is +7, oxygen is -2. And so down here we see those same things and we already figured it out. We don't have to do it again. This is permanganate, this is nitrate, this is nitrate, this is nitrate, and we already know N is +5, oxygen is -2. Here's another nitrate, and permanganate, Mn is +7. Now we can look at everything else. There are no H's bonded to metals, and so we know that the H's are going to be +1. And this problem suddenly became a lot easier. We only have a few things left to figure out. On this side, we need to figure out manganese. And NO3, nitrate, has a charge of -1. Since there are two of them, the total negative charge is -2. But the whole thing adds up to 0. So manganese -2 equals 0. Manganese is +2. Over here, forgive me, but I actually do not know the name of this polyatomic ion, and I don't know its charge, but I do know that it's bonded to a sodium. And I also do know that Rule 1 says that if you're actually ionically bonding, you're going to follow your preferred charge, which tells me sodium is +1. Same over here. It's bonded to nitrate ionically, +1. And this tells me that bismuth O3 must be a polyatomic ion with a charge of -1. And there are 3 oxygens, just like there are 3 oxygens here. And so bismuth and nitrogen here are going to have the same oxidation number because they're doing the same thing with oxygen. On this side, though, bismuth is doing something different. It's acting on its own, and it's ionically bonding with nitrate. 3 of them. Each nitrate is -1. So bismuth -3 is 0, which means bismuth must be +3. Manganese went from 2 to +7. It was oxidized. Bismuth went down from 5 to 3. It was reduced. I hope this video helps with determining oxidation numbers. If you need to watch it a few times, please do that and rely on the rules. These will help you solve any problem. Have a wonderful day.